Yep. Thank you, Kobe. Hi, I'm Andrew Wallender. I am a reporter with Bloomberg Industry Group based in Washington, D.C. I have been covering PFAS for several years now. I've focused a lot on litigation, liability, and different methods of exposure to PFAS as well. So I've kind of had a front row seat to PFAS as it's developed over the past few years, from something that people didn't really know much about and wasn't being talked about that much, to where it is now, where it's this very hot environmental topic. I also maintain the PFAS state activity tracker for my newsroom, where we track legislation and regulations at the state level. So seeing how states are responding to PFAS as well. So given that background, I'm really excited for the conversation we're going to have tonight, where we're going to talk not only about PFAS and what it is and how we got to this position that we're at now, but also really focus on some solutions and the technology that's coming along that's going to help solve some of the issues that have come up with PFAS as well. So we've got a lot to get to in our conversation tonight, but want to start with some introductions of the panelists first. We've got people from a variety of different backgrounds that relate to PFAS in different ways. So we'll start here with Stephanie Benedetto. She previously was a corporate attorney, but now works as a climate fintech entrepreneur. She is the co-founder of Queen of Raw, which is a science-based supply chain software tackling excess inventories and inefficiencies. The software saves companies money and also reduces pollution. She also previously co-founded a sustainable textile manufacturing facility. So she's going to be able to shed some light on PFAS and how it gets into our supply chains and potential solutions that we can approach from the supply chain side. Next up, we've got Lisa Neuberger Fernandez, who's joining us from 374 Water, where she's the global head of sustainability and innovation. She shapes the company's sustainability strategy and works with clients, suppliers, and innovators to coordinate sustainability efforts. So she's going to be able to speak to us about some of the new technologies and solutions that are evolving to tackle PFAS. And finally, we've got Philipp, Wilfert, who is an expert in wastewater treatment and resource recovery. He agreed to join us after his colleague, Dr. Doris van Helm, had an invitation that she had to accept at the same time as this. And I say had to because it was from the King of the Netherlands. So really had to take it. I would also not say no to a king. And so thank you for being here, and very excited that you can join us because Philipp's going to be able to speak to how Europe is dealing with PFAS and how wastewater treatment might offer some potential solutions to PFAS as well. So a little bit more background on Philipp. He received his PhD in environmental biotechnology at Delft University in the Netherlands, where he specialized in phosphate recovery from sewage sludge. So there we have it. That's our panel for tonight. I want to also say that if you're joining us online, thank you for being here. I'm going to have my laptop, so I'll be monitoring questions as they come in. Please ask questions at any point during the conversation tonight. We'll save some time at the end to get to those, but feel free to drop those in whenever they come up. So I guess we'll start with you, Stephanie. Can you give us a little bit of background about PFAS, just looking very broadly what they are, what are these forever chemicals, and how do we get to where we are today, where the media seems to be covering them a lot more?
Thank you, and thank you all for having me and being here. So PFAS, that's the term for thousands of man-made chemicals that have been used in industry, in consumer products worldwide for, since the 1940s. And you think of it and you think of your, Teflon pans, right? And why your mom tells you not to take a knife and scratch that pan, it's because of PFAS. Dear and dear to my heart in the industry I work in is fabrics and textiles. Think of water repellent clothing. This has PFAS in it. Think of stain-resistant carpets and other materials. This has PFAS in it. Even some cosmetics and things that are used that are resistant to oil and grease and water. So PFAS bonds are so strong, and we don't have to get into the chemicals, or others can probably speak better to that than I can. But because of that bond between the fluorine and the carbon, they actually cannot be very well broken apart, earning them until now, which we'll hear about tonight, the name forever chemicals. So as a result, because of this widespread use of these chemicals in all of these products that we all touch, It sits forever in the air, in the water, in the soil. And it's just around, it doesn't break down very well. And as a result, because of these tight bonds we just described, it remains, and their widespread use is now affecting us all. And so because of that, it's become a very hot topic of the day, a lot in the news going on. It's now affecting the blood of a lot of people, in animals presented at low levels in our food. So this is really a very prevalent but a very concerning issue, in that a huge opportunity, which we're going to talk about, of how to do better tomorrow. So nearly every American, from what I have seen, supposedly has it in their body at some level. And I don't want to get too much into the scary statistics. We want to actually talk about how we can solve these issues. But because of that, it actually can affect birth defects. I've read it can affect our immune systems, making it issues with vaccines and having vaccines able to be effective, and it causes high blood pressure. So clearly a scale of a big problem that touches all of us on some level, but exciting that the media has actually picked this up because of all the new regulations going on the state level, on the federal level, which we'll talk about, because of everything going on in the world today. We've all woken up to why this matters and how we have to make a difference and go change the world for us, for our children, and for the future.
Great. And can you put in perspective sort of how the scope of the issue that we're dealing with? So is this a particular issue in the United States, or is it in other countries as well? What's the scope that we're talking about?
Yeah, well, it's obviously, this is an international issue. It's got national implications, and it's even got local implications. On the local level, some of the work we've done just to demonstrate how we can start to take action on these things. We joined with H&M, Unilever, Cisco, Goldman Sachs, and the Ellen MacArthur Foundation. And locally, we created the New York Circular City Initiative. And the goal of that was to actually be able to adopt regulations in the future to help cut down on waste and inefficiency and water pollution and make New York City circular in the coming years. But what was interesting about that conversation in the paper we wrote, it was that by doing that, how many good jobs could be created, how much money could be saved and made, and how much better our water in New York City could be as a result of taking those actions. So just one demonstration of how this can affect at the local level, but clearly also, which I'm sure we'll talk about, the regulations at the state level, the federal level, and internationally, because water moves, it touches all of us everywhere, every single day.
And then we had a bit of news this past week from the EPA, where they announced that they are taking action on 2 types of PFAS. And so to you or to anyone here on this panel, can you give us a little bit more insight on what that is, what the EPA did, what their decision means for how these chemicals are going to be regulated going forward?
I can start and we can add, but in terms of, is this a local or an international issue? So I've read in the paper that PFAS is popping up even in like polar bears. So it's quite international because it can move with the rain, with the clouds. It's in our systems. And a week or two ago, a map of Europe came out in Le Monde that showed the map of Europe and where is PFAS across the continent, and it's quite pervasive. So that really surprised me. And a scientist even explained to me that you see clusters in big cities, and that's not because PFAS isn't outside of the big cities. It's because mostly PFAS had been measured in the water systems in the big cities. So it could be even more than that. Last week, the EPA came out with news about the levels of PFAS in drinking water that will be considered to be acceptable in the United States. And as far as I understand, that will put many water treatment plants kind of out of compliance when that does come online. So this is potentially a very big deal, kind of making seismic waves across the water industry in the United States. Anybody wants to add?
I think I read that it was the first time in 26 years that the EPA has regulated new drinking water standards. Of course, as I understand it, the rule's only proposed, it's not finalized, it's available for comments, so we'll see where it ends up. But it applies to 6 of the forever chemicals. There are still thousands more, but this is what we know we can start to see, treat, regulate, take action on. One interesting thing to think about with that regulation, and of course we're going to talk about, is who is going to bear the cost for actually measuring this stuff and then removing it? And then what are we going to do with it once we remove it? And I believe, as I read the current regulation is proposed, it is going to be us. Your water bill is going to change if they do find high levels of this PFAS and they require you remove it to below that level. So it's something to think about, whether there's a responsibility for the supplier, the person who put it in the water, and why, whether government should step in. A lot to be thought about and discussed, but as Lisa said, it does put a stake in the ground as to what matters, as to where we're going and how we need to be thinking about things and the solutions that are available in order to take action on it.
When you talk about the cost of PFAS, I heard a statistic that last year the U.S. Department of Defense estimated that the cleanup of PFAS only on 700 bases alone could cost up to $29 billion, and that may be an underestimate. So when you think about the cost of PFAS, that gives you a sense of what we're talking about.
And Phil, I'm curious about the situation. I mean, we've got the news from the EPA that they're taking more action on PFAS. What is the situation like in Europe? How are PFAS perceived there? And do you have a sense for how regulators are approaching this class of chemicals?
Mm-hmm. And in Germany, situation, or in Europe, the situation is similar what we heard. First of all, it's measured everywhere in all organisms, in all types of environments, water, air, soil. And the health aspects have been established, of course, and costs quantified. So that in the last 10, 20 years cost quite some attention, raised quite some attention. And then on top of that, it was all amplified by some very prominent cases that we had in production facilities. We measured really high PFAS concentrations all over Europe. And that was, for instance, in the Netherlands, Belgium, Italy. And of course, there were also some incidences in places where firefighting training takes place, so, because PFAS are often used in firefighting foams. And for instance, in Germany, not far from my area, there was an important case where there was a sewage sludge brought to agricultural land. And there was also some industrial sludge in it. And that contained PFAS. And this agricultural land is now lost for quite some time, or contaminated. So the whole area is affected by that. And that led indeed to quite some regulation activities. So the regulators became active. First of all, there are some regulation under development that completely bans, or is planning to completely ban PFAS production, import, export in the European Union. There are regulations on the way to monitor surface waters, all surface waters. And what is already in place is that there's PFAS regulations in the drinking water. And that there's a transition phase until 2026. And then these thresholds have to be met. And just to give you an example, that in the Netherlands, 1 out of 10 drinking water treatment plants was not fulfilling this criteria. So that shows there is some need for action. And that is the German or European.
Right. I'm curious too, as you talk about regulations, I know there's been a lot of discussion here in the United States about whether we should look at PFAS of a class of 6,000 or so chemicals all together, these substances all together, and regulate it en masse, or should we look at a few of these at a time, some of the most dangerous ones like PFOA or PFAS, and regulate them sort of as we learn more about these individual substances. Do you know if in Europe they're sort of treating PFAS as a class of chemicals, or kind of doing it like in the US where we're looking at specific chemicals individually first?
No, the idea is to treat them as a group of chemicals, because the industry came up when one substance or one single compound was forbidden, another one came up. So the idea is in future to treat them as a group. And that causes, of course, quite some shaking in the industry, and we have to see where the legislation ends up. That's currently under discussion, how to deal with it. But the plan is to treat it as a group.
And then getting to some solutions here, Lisa, I'm curious if you can shed some light on what 374 Water is doing about PFAS and bring up some more about the Reimagining the Future of PFAS initiative that you're involved in.
Yeah, absolutely. So it's really exciting for us to be at Nasdaq today to launch this new initiative called Sustainable Futures, which is an initiative that 374 Water has launched in order to bring together pioneers and practitioners who are on the front lines of driving clean water, clean energy, waste, and the circular economy to come together to learn, to innovate, and to take action on big challenges. So we're starting with the biggest challenge that we have on our radar today, which is the future of PFAS. And so today we launch a call to action to tackle the PFAS challenge that we've just been talking about. And with this call to action, we've brought together a brain trust of experts, cross-sector experts, academics like Philipp and his colleague Doris, academics from around the world, number of corporates and startups, as well as policymakers and others who are kind of joining, banding arms together and saying, what can we do about this challenge? And so together with this brain trust who came together virtually last week to kick this off, we came up with a call to action framework. And so we think about what's it going to take to kind of change the conversation and shift to a focus on where is the investment and the innovation required to make a difference on PFAS. So we've come up with four main areas, four main solution pathways, if you'd like. And the first one is all about, curbing at the source, the production and of the chemicals and the materials of the products that are using PFAS. And the next area is all about cleaning up the mess. That's where technologies like the supercritical water oxidation technology that 374 Water is bringing to market, that's where we come in, companies like ours come in. And the next step is about creating alternatives, new chemicals and new products that do not use the harmful compounds that we've been talking about. And one of the academics in our group from Duke University pointed out to us that it's during that process of change, of introducing new chemicals and changing the compounds, which Philipp was just describing, during that changeover process, that innovation process, that actually the greatest risk of human exposure exists, because those new chemicals will not have been tested. It may take years, decades longer for those to be fully, tested and potentially regulated on. So that's an exciting time for innovation, but it's also a potentially dangerous time for human exposure. And then the fourth area is about behavior change. So if we have these new products, and I hope we'll come on to the one of these newfangled products that Stephanie is actually wearing a special material here. We'll come right back to that. But this is a shirt that does not have PFAS in its material, but it has the same properties as PFAS. But in terms of water resistant, stain resistant, these types of things. But the behavior change comes in because if the materials do not have the exact same properties as PFAS, then we may need to change the way we use things. If we need to add wax to a shirt or to shoes or whatever it may be, or in an industrial case, we may need to change the maintenance schedules. So if a window on the skyscraper does not have the protective coating from PFAS, maybe it needs to be reapplied at a faster rate than the PFAS rate. That's just pure speculation on my part, but there are industrial changes that would need to be made. These are behavior changes. So driving that adoption of these behavior changes it's actually a big deal and much harder than some of the other elements that I mentioned. So that's what we're kicking off today. Call to action, the future of PFAS.
Yeah, so you mentioned a bit about curbing at the source. So Stephanie, I want to turn to you and ask a little bit about consumer products. And if you can talk about how PFAS gets into consumer products and sort of where your software fits into all of this.
Happy to. So obviously textiles touch everyone all over, of course. It's our clothing. It's also the material on your chair, the inside of your car, the carpet under your feet. And clearly a lot of this, as we just described, does have PFAS in it. So how do you know what's actually touching your body? And when you're going to buy something new, how do you know if it does or doesn't have it, right? Those are real challenges. And as Lisa was just describing, in order to change that behavior, you have to know. So we spent a lot of time, and the focus in our software had been around first identifying what businesses have in their inventories, existing and excess inventory. Of course, part of our software is about helping them reduce the amount of textile waste, bring down the amount of textile production annually, and thereby save a lot of clean water. But also for the stuff they do have, how can you test, measure, and report what is actually in it? Know, what is it made of? Where did it come from? Who does it go to? And if it has PFAS, what to do with it? So that's a big part of where our software leverages blockchain and machine learning AI and a lot of testing partnerships in order to help identify as close to the source as we can what doesn't have PFAS in it. And to the excitement of innovation and what I'm wearing, this shirt is just one example where you don't actually have to change your consumer behavior in order to wear clothing that isn't made with PFAS. I went to a store, right? You can buy this shirt now by an incredible technology innovation company. It is the same price or even cheaper than a typical, cotton button-down suit shirt. And it is made all naturally, no PFAS, no chemicals, no additives. It is totally sweat, stain, and odor resistant. I've worn it in the shower. I've poured bottles of wine on it, and I've never had to dry clean or wash it once in its life. And if you touch it and feel it.
That's different than most shirts.
That is quite right. And if you touch it and you feel it, it feels the same. And so I didn't have to make any judgment call or change in my behavior other than knowing that this was a pretty cool shirt, same price and same properties. So I think those are the kinds of innovations and where we're going to truly automate and scale this. I know as a consumer the impact I'm having, the company knows the impact it's having, and this is how we get widespread adoption.
And so one thing I'm hoping you can shed some light on as someone who is an expert in supply chains is how much end manufacturers and retailers can see sort of what is going into the products. There's a few laws that are coming have been introduced or bills that have been introduced in states, and in Maine at least they have a law coming on where they're going to be required to notify people when there's PFAS in products. So how hard is it for a retailer and manufacturer to know what their supplies have in that?
I'm a lawyer. I have to say it depends, right? The obnoxious lawyer answer. I mean, we know what we know and we don't know what we don't know. And if you think of, fashion, but any supply chain, hundreds of steps across the globe, metric tons of water, chemicals, crops, oil used in the process. So the bad news is it's very hard to know, especially when you have from a tier 1 to like a tier 14 deep supplier to make something. It's very hard to know what's going on that deep in your supply chain. But the good news is there's such incredible innovations going on right now in technologies that you are able to test and measure and report. With our software, you can go deep and see what's going on down to a tier 14 supplier and actually take action when and if you see an issue or a challenge. So I think regulation and all the changes going on is one piece of it. It definitely causes big enterprise companies to adopt these changes because they know they have to in the face of regulation. But you have to know where do you go and what do you do on day one as you continue to try to get deeper into your supply chain and do better. So I think that the time is right for these kinds of innovations, but you can't expect companies to change overnight, to your point, and know everything going on perfectly from farm to finished good to end of life and around again. That's unrealistic. But you can know what you have right now, you can test, and you can then go up and down the chain from there. And that's what I'm excited to see.
And to zoom out a little bit more, can you explain why PFAS is in these products to begin with? What the purpose is there?
Oh, I mean, they added so many incredible properties at the time, for lack of a better word. It made things, as I said, water repellent, stain, sweat, odor resistant. Same with carpeting, with our clothing. This was an easy add-on that was not known to be as dangerous at the time that had these properties that were so beneficial and valuable to people. We just didn't know at the time, and thanks to science we do now, the negative implication of this. But we need to find alternatives that are able to behave, as I described with this shirt, that same way, while not having the PFAS application, of course, chemicals in it.
And then I want to turn to wastewater, which is your specialty, Philipp. And so I'm curious how your field of work relates to PFAS and what some of the crossovers might be there.
Yeah, of course, some of the PFAS also is ending up in the wastewater, and that is coming from industry and also from households. There's part of the PFAS which is ending up in soils or agricultural land we don't see.
In our bodies, right? Sewage process.
Yes. Yeah. And of course, ideal would be to treat everything at the source, especially for industrial sources. But that's not the case. So the PFAS goes together with the wastewater in the sewage treatment plant. Partly a small fraction goes to the sludge. A large fraction just passes through the current treatment processes because biology in the wastewater treatment plant will not degrade any of this material. So it will, at the end up in the surface waters. If you want to eliminate that, you need additional treatments like reverse osmosis, activated carbon, particulate or granular activated carbon, or ion exchange. And they are expensive, and most of them also don't destroy the PFAS. They just take them out of the system. So there's some additional treatment needed. But what is maybe also interesting to add, also related to the costs, what we discussed before. In Europe, there is currently a draft for the Urban Wastewater Treatment Directive that regulates everything about wastewater treatment in Europe. And there is the plan to include another treatment step to eliminate chemicals from pharmaceuticals and cosmetics. And with similar technologies that would be needed for PFAS. And what is also interesting there is that actually that's the polluter pay principle. So the companies that produce the material have to pay. And they're currently, you can comment on this draft. There are NGOs and different water companies and associations commenting why not put PFAS there on top of this list as well. So also add industrial chemicals.
And so what's the research that you and your colleagues are doing, and how might that relate to PFAS as well?
Yeah, we have colleagues from TU Delft, it's a group from Doris van Haarlem. They are looking at other mechanisms to remove PFAS from water, from bulk water or reverse osmosis brines. So that's the concentrates of water treatment. And they look for novel adsorbents, for instance, zeolite-based, and these compounds currently that's done with activated carbon. But these new materials, they have some advantages that they are reusable, so you can regenerate them multiple times. So the capex is much lower. And there are also some colleagues looking into electrochemical removal or elimination of PFAS. And some colleagues in the Netherlands I know work on biological ways to concentrate PFAS and eliminate it. And maybe I can add why I'm also interested in this topic, because I'm working mainly on resource recoveries. We try to turn wastewater treatment plants into resource factories. So we didn't see wastewater as a waste, but we think there are a lot of valuable things in it. And I would like to hear one day about the technologies that you are using to remove PFAS. Is there maybe a way to combine them with our knowledge and know-how to recover some resources? For instance, we work on desalination, and we are able to recover salts from the brines of this desalination and also recover acids and base. So maybe similar options are possible in this setting as well.
Definitely have something to talk about.
Yeah. and can you talk a little bit about 374 Water's technology and how that works?
Yeah, absolutely. So, of course, Philipp teed us up perfectly well, and I think he might have known what he was doing possibly, but thank you for that. So what Philipp was describing is a process where PFAS and other contaminants are coming through the waste treatment system and through the water treatment system, and the contaminants are getting kind of pulled over to the side by the filtering process that he was describing using more complex words like granular activated carbon and resins and all kinds of things. But it's essentially a filter. So that's step one. But where 374 water comes in is step two, because the filter still has all of the contaminants in it. And so 374 water's technology is able to take those highly concentrated toxic contaminants and to transform that waste into its underlying elements, which are the clean water and energy, which can go back into to power the system, minerals, which can hopefully be recovered as you described, maybe phosphorus, maybe fluoride, maybe other minerals, and then the carbon that has been separated from the other molecules. So 374 water uses a process called supercritical water oxidation. We go by the phrase SCWO. Next week is SCWO week in Indiana, where our partner who's sitting in the room here, Terry Merrill, and his company is helping us to assemble, the first unit, which is actually going to a wastewater treatment plant in California. It's called Orange County Sanitation, and this is a tremendously exciting first customer for 374 water, because OCSAN is known to be one of the most innovative, one of the most forward-looking waste treatment plants in the entire United States. So we were thrilled, we're thrilled to collaborate with them. They're a great partner, and there's a great article about this collaboration in the LA Times, which you can easily find. So that's a kind of starting point to your question.
So I'm curious too, is there any waste product that's produced as you're cleaning out these chemicals? Is there like any concentrated PFAS or anything like that comes out as a result?
Yeah. So what's really fascinating about this technology, and I'm really excited to see it working, hopefully next week, is that the supercritical water oxidation, it's a process that uses extremely high heat. So the reason that our company is called 374 water is because it's referring to 374 Celsius, high temperature, or you could say 705 Fahrenheit. So at high heat and high pressure, water turns into a fourth state that I had never heard of until I joined this company. So it's no longer a liquid, it's no longer a solid like ice, it's no longer a vapor. No, water turns into this fourth state, which is called supercritical. And in supercritical conditions, water turns into a magical solvent. And that solvent can cut the carbon bond and break molecules and compounds into their underlying elements, as I mentioned before, into the clean water, the energy that goes back to power the system, the minerals, and the carbon. And so what is the effluent that's coming out? So there is a water effluent that comes out, there's a mineral effluent that comes out. So imagine minerals, sedentary minerals at the bottom of the water, and a bit of carbon will come out of the vent. We hope to be able to capture that carbon in different ways, or bring it back into the industrial process through carbonated beverages, et cetera. And the other thing that's really interesting, the last thing that I will say about this technology, is that we're able to destroy or eliminate the contaminants without adding more pollution through the process. So the oxidant in our process is actually air. It's not another chemical. So in that way, it's an extremely clean process to run. And so there are no additional chemicals that are brought into the process that would be a new type of waste. Mm-hmm. So we are able to eliminate pollution without adding more pollution.
Right. Because one thing I've been hearing from different water suppliers and interviews and stuff I've been doing is that they're worried about ending up with a very concentrated substance of PFAS that then have to deal with and not cause further pollution. So that adds another stressor. Yeah.
Exactly. Yeah. And so what's amazing, and we have some research coming out from our co-founder, Mark DeSuze, that has been published or is about to be published, that's actually looking at the exact levels of PFAS that have been destroyed and that are remaining after this process. Mm-hmm. And it's to the fourth number log 99.99. Tell me the right number percent here has been destroyed, mm-hmm. which is not 100%, but we're getting as close as we can get.
And so how you mentioned the first unit is coming online or close to coming online soon. How far along is the technology and how many places do you hope to deploy it?
Well, we hope to deploy it, all over the world. And the technology has been in operation in its first phase at Duke University for the last 6 to 8 years, and it has apparently been, sitting in the parking lot behind the dean's office. So we know it's safe, we know it's odorless, we know it's soundless, we know that it works, and we're excited to bring our first unit online to OCSAN in the next couple of months. We also have signed, or we're, I don't know what the right word is, but we're working with different parts of the Department of Defense to bring this technology to test this technology at bases in different parts of the country, and then go on and on from there.
Mm-hmm. Awesome. Well, I want to open it up to some questions around the room. We've got one question online that I will read, but please think of questions if you'd like to ask anything. So the question here is for the technical people on the panel: do you see opportunities to combine PFAS removal and waste to energy conversion?
Yeah, well, that is a great question. And as I was describing, the way that the 374 Waters technology works, it is actually doing both removing PFAS and converting waste to energy. And the energy that we create through our supercritical water oxidation process, we actually pour it right back into that process. So that makes our technology very energy efficient, as a result of being able to reuse that energy. You may, in your circular recovery, you may have a thought.
To be honest, I don't know the technology well enough to feel like giving a statement.
Thank you for that.
Yeah, no, well, so from my point of view, a lot of the work we do obviously is about taking waste, reducing the amount of waste, and reducing the environmental impacts. But obviously, as a part of this, there is some waste that, with the way our software works, that is going to be reused. And so when we're measuring and reporting on the waste that gets reused, a big thing that we thought about is, okay, for some of the synthetics that we haven't phased out yet completely, what are we going to do with it? And if someone's going to reuse it, there's a value in that, but there may be PFAS in it. And so we wanted to be a part of solving that downstream challenge. So we joined forces with Under Armour, Canopy, and a bunch of other organizations, and we put together the Microfiber Plastic Pollution Challenge. And we put real money behind finding a lot of innovations. Ours obviously very specific to the textile industry, but that can look at microfiber plastics and PFAS even further downstream and be able to actually solve for it. So we have some incredible companies, incredible innovations. And I think, in addition to what you're doing, there is so much exciting innovation happening here around that we just now are at the point where, as you're demonstrating how amazing it is, getting that worldwide adoption of this stuff. And it's not that far away. I think so long there's been this feeling that circular economy or sustainability is good for pilot projects or little eco-conscious collections. But I hope all of us up here have shown and have talked about how this can truly be done automated at scale across industries and around the world with these innovations. And, today our company, our software has saved over 1 billion gallons of water, and we feel like we're just getting started. So obviously never doubt that all these actions that we're all taking and that you take can and will change the world.
And then another question is when the first unit will be shipped to Orange County.
Yeah, that's a great question. And some of the people in the room can answer that question, but I'm going to say that we are shipping, in the next couple of months. And if anybody in the room wants to make a more precise answer, I will leave that to them.
Can I ask a question, please? Just you talk more about how the system, 374 system scales. So if you're thinking about 15,000 drinking wastewater plants, 55,000 US drinking water plants. What's the scale? What's the throughput? How many gallons per minute can be processed? Just some color there.
Absolutely. So the system that we're producing for OCSAN, it processes 6 tons of wastewater per day. correct? And then it goes up from there. And what OCSAN has said is that they're looking to see how this works, and they'd love to be able to bring in the next size and the next size and to go from there. We're very clear on the addressable market across the United States and internationally, and we're working as fast as we can to get the system up and running safely and to be able to expand and take advantage of that. But the size of the problem, as we've just described, is huge. So there's tremendous potential for scale of this technology.
So does it scale in a reactor, or you get a chain of reactors, a train of them, or you get a larger reactor? I'm not sure if I'm using the right term.
Yeah, so just to add a little bit of color into that. So the way that we are really attacking the market is by mass producing our equipment. We are mass producing it. We're, as Lisa mentioned, the small scale system that we have is 6 tons per day. From those 15,000 utilities that you just mentioned, that specific product can address about 5,000 of those utilities, the small scale, small town. And what we're doing right now is also scaling up our production to 30 tons. So that's going to address another 5,000 utilities from that market. What we are going to do for big utilities, big centralized system that already exists, that's going to be addressed by our large scale system, 200 tons per day in terms of sludge management.
Is it a continuous process or is it batch?
Continuous process.
And then another question we have online is how do we ensure the alternatives to these products are not harmful in ways we are not yet aware? Is the precautionary principle applied? So Philipp can speak to.
Yeah, absolutely. As I described earlier, when things are changing, that's the time when new things can be created that could be more harmful, less harmful than the alternative. When I think about adoption of new technologies and innovation, what's really important to realize is that innovation is only as good as the adoption. You can have the most newfangled product or system around, but until it's adopted at scale, we have not reached the full potential of that.
Would the final product at your OC site, would that be compliant with the recommended EPA 6 parts per trillion?
I should hope so.
Okay, so would it need any other further filtering, anything beyond that, or just right out of the reactor, it's compliant?
It's all a matter of the inlet concentration, of course, right? We are doing 4 or 5 log reduction on PFAS. So that's what ultimately will dictate the concentration on the back end. And we see the pathway of reducing that to very close to 0.
And this question kind of flows into that. It comes from online as well. With the supercritical process, you mentioned filtering the water when entering the process. What is being filtered or concentrated as it goes in?
Yeah, so I realized I didn't finish Philipp's story. So Philipp described a process where waste comes in, it's full of contaminants, and the contaminants are filtered off to the side. Now, and the water continues on its merry way. And what 374 water technology is going to do with OCSAN's waste is that we're actually going to take the filter. We're going to take the filter that's full of the contaminants, and we're going to put the filter through the process and take the filtered materials that's absorbed the PFAS and other contaminants, and we're going to eliminate that. So in comes the filters full of the contaminants, and out comes the things that I've described before: the clean water, the minerals cleaned of the contaminants, and the energy and the carbon.
And then another question related to that is for the Orange County installation. What percentage of their waste is that going to be handling, the unit that you're going to be installing?
That's a great question, which I cannot answer.
Anyone else can speak to that?
Yeah, it's only about a 2%, right? The Orange County facility is one of the largest wastewater treatment facilities. They serve about 2.6 million people. Our unit from the sludge production, the biosolids that we want to treat, it's about 2% of. But what we're looking on our technology is really giving those utilities the right tool, so they can really treat the hard to treat material in our system and have the capability of choosing which ways to treat. But obviously we are scaling the technology and we're going to deploy a bigger scale system.
One of the interesting things about this technology, which I haven't mentioned, is that it's a decentralized technology. So we bring this technology and we put it on site, whether that is at OC San at the end of the pipe once the filtering process is done, or whether it's in a community, or whether it's in a pharmaceutical plant or wherever it is. So by using this decentralized technology, we're able to leapfrog and to actually help with the adoption of the technology, because we make it easier by inserting the technology into that right step in the process.
And I want to offer a chance for anyone in the room, if you have any questions at all or comments that you want to add. If not, we've got a few more questions online that we can get to.
I'd throw one in for Phil. I was really interested in how you listed some of the alternative treatments, that there are flaws in all of them or just shortcomings in all of them, whether it's electrodeionization, activated carbon, and so forth. Could just talk about the all-in costs, like for the energy, getting to 374 in my mind, I've got to understand what type of energy does that require, and are the utilities set up for that? Just maybe if you look at it on a total input costs, including energy, how does 374 stack?
Some of the technologies I was talking about, they are what you described what Lisa described they are more concentrating steps. So you have to imagine you have a bulk liquid with the PFAS in there, and then you have different concentration methods which accumulate the PFAS, and that's, for instance, the activated carbon or other novel adsorbents that we develop, or that is reverse osmosis, which is basically membranes concentrate the PFAS, and they are not doing the job of destroying anything. So there's no energy balance that I can bring upon. There would be other methods that need to be compared, maybe incineration. And the method of this electrochemical elimination or destruction of PFAS, as far as I know, this is at a quite early stage. So I would not know how from the energy balance that relates to the technology we feel.
The thing to remember about the supercritical water oxidation process is that by creating energy that can be put back into the process, it's energy efficient in that sense.
Thank you.
And question for Stephanie, can you say the name of the manufacturer of the PFAS t-shirt?
Oh yeah, of course. Drapel Fabrics. They're a great company, and happy to share information about that as well. But one example of many that are doing great work. Mango Materials is another. Pangai and MIT did some work. There's some great innovations out there that are just at the beginning.
And then another part to that question also is, are there any avenues right now for federal, state governments to be giving tax breaks to innovative companies?
Yeah, we look at this a lot, right? And how do you incentivize action? And we talked a little bit about who should bear costs for things. And so I definitely think we're just at the beginning of seeing with this climate crisis, but climate opportunity and what's going on in the world about how we can spread out those costs and incentivize good action. So I think, carbon credits and tax credits, whether there's, regulation that puts, costs onto the suppliers who are causing this, whether it's us as end consumers participating in solutions like this and getting credits and coupons and loyalty points for doing that. There's so much that we're just at the beginning of seeing, but absolutely a key part of this is going to be getting the unit economics right, making sure everyone knows the impact that they have, and obviously are incentivized to take action, all stakeholders across the chain.
And then another question about textiles is what makes them waterproof? I'm not sure if that's in reference to the new stuff or the old stuff.
So I wish I could speak. I am not a material scientist to how they actually do it. And I know it's a proprietary process, but it's something with the twisting of the warp and the weft of the material that releases some natural properties that give it this like natural behavior. So can't speak any more to that. Definitely check them out and I can connect you with them. But that does beg an interesting question. If you want to know more, a lot of these innovations at early stages are still proprietary, whether they're patented, they're trade secrets. And as we get further down this road, are there opportunities with all of our innovations to democratize access to this technology so that everybody can know and understand these kinds of properties and adopt these innovations? So, a lot to be thought through in what you're doing. One of the things we did is now looking at, we have a measuring score to help textile industry measure and report the water, chemicals, carbon emissions, waste, and dollars saved by the activities. We built that with MIT, and now how do we open that up to others? So a lot of opportunities to do that.
A question perhaps for Philipp. Is there a quick test on the effluent to ensure PF chemistries are destroyed? Sounds like the results are a given.
As far as I know, there are no quick tests for PFAS. I know that in the Netherlands and also in Germany, it took quite some years actually to establish the analytics. So it was collaboration of different institutions, and as far as I know, no quick tests, unfortunately.
And then
in the room, we have a question.
Oh yes, please.
Is this only the end market currently? Is it only the wastewater utilities, or can it be also applicable to the to industrial? So in industrial water, so you can, if they're creating something, you can just destroy them, and then it's a circular.
Yeah, absolutely. In the case of 374 Water, our customers are, there are multiple segments. So we've talked about the municipal utilities, we've talked about the defense, and then in the industry side, there are multiple industries that we're engaging with. One is pharmaceuticals, another is food and beverage, and another could be oil and gas, and kind of on and on. And certainly the circular solutions are critical to the value proposition here. And if there's a way to reuse the clean water that's coming out, to reuse the minerals that are coming out, et cetera, that makes the solution even more powerful.
Mm-hmm.
We're almost out of time, but there's a few more questions about 374 process. So maybe just rapid fire a couple of, I'll throw some out.
I'll do my best.
Is it going to rely on electricity to generate 374 degree temperature is one of the questions. Another, is the system designed more for liquids or for solids? And then can the process remove other chemicals as well? There are other chemicals in the waste stream that are difficult to remove, things like ibuprofen, other things.
Yeah, absolutely. Well, let me start with the third one, because the beauty of supercritical water oxidation is that it is an omnivore, or there's another word that we like to use.
Yeah, omniprocessor.
Omniprocessor. This technology is an omniprocessor, so any contaminant, any organic material can be dematerialized or disintegrated as a result of this process. So it can work for pharmaceuticals in the environment, like that was an example just made. It can work for dioxin. It can work for other toxins, PFAS, microplastics, anything that has an organic matter at the start, carbon base, et cetera. And what were the other ones?
Liquids or
liquids
or solids, and then the temperature.
So to move through the process, the material needs to be in a liquid form. So not like this cannot go through the SCWO machine.
How could the membrane go through that?
So it is able to turn into more of a liquefied process.
So it destroys the membrane.
I suppose so.
Yeah, like slurries,
Yeah.
basically.
And then the energy it requires to get up to that.
Oh, sure. Yeah, so I know it sounds kind of extreme, but the way the process works, the energy is really used to kickstart the SCWO process, and then once it gets going, because the energy is recovered and converted back into the system, it becomes self-fulfilling, self-powered process to a large extent.
Well, as we wrap up, before we do, I just want to go around one last time and maybe share one thing you're hopeful about for the future when it comes to PFAS, either a new technology that's on the horizon or regulations that are coming into place, something of that sort that makes you hopeful. So, Philipp, do you want to start?
Yeah, I'm talking about, of course, the wastewater treatment field. For me, it would be nice to see this PFAS integrated in resource recovery, so we can see what chances are there. And I think for Europe and also for you, it would be nice if Europe would really ban this PFAS also in the effluents of wastewater treatment plants become active, so that every wastewater treatment plant is actually forced to do something there. And I'm curious how that will develop over the next years.
Yeah, so why did we create this future of PFAS call to action? Well, we really want to change the conversation from the fear and perhaps the paralysis of thinking of such a massive challenge. And we want to shift the conversation to optimism and to action. And really to say, this is what it will take. We're going to have to all, roll up our sleeves. No one company, small or large, can do this alone. We need to have cross-sector collaboration and collective action to really focus on the solution pathways. And that there are solution pathways, and the key is how do we, build that momentum and kind of turn the tide on getting us to the next generation where PFAS is not a problem. That's some years down the line, but we are excited to really spark that, and we hope that this kind of a conversation, this kind of education and inspiration will really inspire people to understand there's steps that I can take, whether I'm a consumer, whether I'm in a company, whether I'm in the government, and how do I take those actions. And if anybody is interested in getting involved in the future of PFAS Brain Trust or this call to action, you know where to find me.
Well, in the spirit of optimism and thinking of the future, I'll just end quickly with a personal story. I was pushing my 3-year-old son in the New York City streets, and it was very loud one day. And I hear over the noise something coming out of the stroller. And I leaned in and I hear, "Are you naked right now? You're not, because you're using fabric. It's everywhere and it's polluting your water." And my kid was doing my 60-second pitch. Now, on the one time, I probably had pitched my company a few times while pushing the stroller. But on the other time, I thought about it. If a 3-year-old can understand this, we all can understand this, and we can and will then change the world for them.
On that note, thank you so much to everyone here, and thank you for joining us. And that concludes the panel.
Thank you.
Thank you.
Thank you.
Thank you.
Wonderful.